This video looks at alkenes. Now, alkenes, when we're talking about organic compounds, are a carbon-based compound that has a double bond located in the carbon chain. So you're going to see our C to C double bond present somewhere on that chain. The other thing we can look at when we're trying to decide whether something is an alkene is looking at the chemical formula of that hydrocarbon or by looking at the name. So if you see that the chemical formula follows this pattern of CN H2N. So if it follows this pattern, the number of carbons that we have should be, that number of carbons should be 2 times that number to give us the number of hydrogens. That's going to give us the general formula for a substance that would be considered an alkene. Okay, and if you're looking at the chemical name, if you see "ene" at the end, that's what's going to help us identify that that substance is an alkene. So we might see something like pentene, okay, for a name. And the interesting thing about these ones is you'll start to see a number in front of the compound, and we'll get in more into that as we're naming. So you might see something like 2-pentene. The chemical formula for this, since pentene is talking about 5, our chemical formula is C5. And then to follow that same pattern, we would have to have 10 hydrogens for our 2-pentene. So when we draw this structure, we know there's going to be a double bond. And in the name, if you have the name, it actually tells you where the double bond should be. So if we're drawing it as 2-pentene, that means at carbon 2 is where my double bond would start. And then we draw the rest of the carbons into our structure, single bonded in. And so that double bond being located at carbon 2 is going to give us that 2-pentene. And then we just have to fill in the bonding capacity for carbon to make sure that each carbon has 4 bonds around it. So if we look, the second carbon has 3 bonds around it, so it only needs 1 hydrogen. And same with this next carbon. Here we're going to need 2 hydrogens to get 4 bonds around that carbon. And on the last carbon, we're going to need 3 hydrogens to end up bonded with 4 bonds around that carbon. So this would be our structure for 2-pentene, or C5H10. Another example we could do that could follow that same pattern could be something like C4H8. Right? So if we have this particular structure, and let's say we don't know the name of it, but we know it follows that CnH2n pattern that we see, we could use our knowledge of how this thing works to then draw the structure. So I could have my double bond at carbon 1, and I could draw my structure like this. And to follow again, I got to have 4 bonds around each carbon. So I'll have 2 hydrogens on the first, 1 on the second carbon, and then my third carbon gets 2 hydrogens to fill its bonding capacity, and the last carbon is going to get 3 hydrogens. So there's our C4H8. That's one way we could draw it. Or, because we don't have the name, it could have been drawn like this, where the double bond is located at the second carbon in our structure. And we could get something like this. So a couple different ways to draw them when you only have the chemical formula. The other way somebody might do is, let's put the triple bond at carbon 3. But if you imagine that, just flip the first drawing we did around, it's the exact same thing. So when you'll see when you look at names that they might have numbers on them, but you'll see that they're always a lower number. They're not going to end up being on the last carbon. So if we were to take a look at how this one would be named, it would be called 1-butene, whereas this one would be 2-butene. Okay. So there's 2 ways to draw that structure with that chemical formula. And when we're dealing with that particular structure, this is where you start to get into why there are so many different organic compounds and how the structure of them can lead to having different properties. That double bond at carbon 1 versus a double bond at carbon 2, it's going to change its properties and gets into the idea of what we call isomers. And we'll learn more about that in the later in our unit. We just want to make sure that we understand that an alkene is something that's going to follow that CnH2n general formula. If you look at the name, it's going to end in "ene," so you'll see each of these examples. We've our name ends in "ene," and that an alkene is something that has a double bond in it, as we see in these structures that we've drawn.